Hi guys, today we are going to move away from switches onto another set of switches, but this time a switch which is very practical to use and pretty helpful in tough situations where you want to power a device which has a high potential using a low power logic so that you don't fry your circuit and at the same time ensure that there is safety involved. And that brings us to relays. So relays are really interesting components in our electronic journey, and you'll come across them in multiple applications anywhere where you are powering, say, a powerful turbine, or you're powering a generator, and you have a logic set where you want to power the generator after 30 seconds or after an hour, or any use case that you can think of. Now you have your microcontroller or your electronic circuit which can do the calculation for you, but to power the generator you will need a power source which is at least 240 volts AC for us, and for that you can't connect them directly using a switch. The reason being that it will fry up your entire circuit and you would be left with nothing. And that brings us to this amazing component called the relay. So how a relay works is it takes a small input. So for example, if we look at this relay, it takes in a 5-volt input and it is capable of providing an output of 10 amperes and 24 volt DC or 128 volt AC. So similarly, you get relays which are higher in size, which can carry a higher current and electronic voltage. And today what we are going to see is how this relay works. So before we go there, I would just want to quickly bring up the circuit for the relay. So right here, I have our relay. I have flipped it upside down along with the schematic representation of how it looks like. So it has our 3 points A, B, C, which you see right here, and 2 points NO and NC. Now I'll quickly explain to you what this is. Now a relay is a small electromagnet with point C connected to any one end, which is normally closed. So what that means is when the relay is not energized, this point is connected to normally closed or normally open, and it will always remain so until unless there is an energy being passed to the relay. In that case, what will happen is the relay would do a switching effect and the indicator would move away from normally closed and onto normally open, or vice versa. And that is how you can use a relay to power devices and also use it as a switching circuit. So how does point C and what is the point that is connected? That's how would we find out what connects what. So if you take a digital meter or any other potentiometer, you'll see there's a connectivity option there, and you can simply connect these 2 points on these 2 points. The one which shows a connection means that is your normally closed, or that part of the circuit is connected when you have your relay in an unenergized state. Now we are going to move on to a simple application today. What we are going to do is part 2 of our LEDs. Now LED 1 would be connected to our relay, and in elementary 2 would be connected to an external power source via battery so that we don't burn it off, and we'll have a switch here. So on an uninitialized stage, our LED 1 will work. As soon as we turn the switch on, LED 2 will work, which will go on to demonstrate how a relay can be used as a switching circuit, or how a relay can be used to power multiple devices. So let's go ahead and bring out the components. So on my left, we have our all famous breadboard. We have got two 9-volt batteries which would be powering the circuit right here and here. We also have our LEDs, our resistor, and a switch. So what we're going to do first is connect the relay to the breadboard. That's going to be our first step. And we're going to pick up points and just leave a slight gap so that we know where those points are and we can use it at a later point of time. Now we are going to connect our switch. So let's take our switch and we will place it somewhere here. Now let us give power to our switch by connecting our 9-volt battery source. Now our switch is connected to our battery source, and we can take one end of this switch, which is the positive end, and connect it to our point A. So this is our positive point. We connect it to point A right here, and we take the negative from the switch and we connect it right here. Now we need to connect a 5k resistor to the common point, and through that we'll connect a second battery source. This is where keeping a slight gap between the relay helps out, because you can clearly tell on which line I have to put my resistor in. So I put my resistor right here, and to this resistor I connect the positive of my battery power source. So I have connected the power source to our helpful male-to-male wires, and this is where our positive will go. And now the negative will go to a point where it will be connected to the LEDs. Now as you can see, the negative of the LED needs to be connected to our normally open and normally closed points, and since we haven't determined that yet, I'm going to randomly assign them right here. Got one, and we take LED number 2. The longer side is the positive, and we place it here. Now what we are going to utilize here is the fact that all the negative pins can be used in the same line on the side threshold of the breadboard. So we are going to use that today, and we are going to take our power source and connect it to the negative. And lastly, we'll take the negative and connect it here, and as soon as I connect the switch, the LED is powered. So now let's just take a quick look at this circuit before we see if it's actually functioning. So I've got my first battery, which is connected via a switch right here to these two contacts, which is keeping this light on. Now as soon this circuit is currently in its off state, so this LED is being powered through this back circuit, which is powered by the second battery right here, and through this K resistor and the common. Now as soon as I hit the switch, what happened was the common and the normally closed connection broke, and a new connection was created between the common point and the normally open point, and this is how our LEDs are switching. So the switching frequency is also pretty high, although for this example, since we are manually doing it, it doesn't make a lot of difference. But if you want to connect it to an oscillator or any other electronic equipment, the relay can handle a very fast switching speed, which is also one of the reasons that relays are used. So this was a small practical example of how relays can be used to power stuff. The most common example for this is if you're using an autonomous robot, or if you want to do anything with a microcontroller which has a 5-volt output and you want to run motors for a toy car or anything. That is where relays come into play. Practical applications may include pumps, or any other electronic instrument which need to be powered on at a specific point of time. I hope you guys enjoyed this lesson. If you have any questions, please leave it in the comment section below. Thank you.